Greetings, I'm still the Sultan of IB Astrophysics, and we're going to talk about magnitude. This is used to rate how bright stars are. We'll talk about apparent magnitude and absolute magnitude. This is a ridiculous numerical scale, but people use it anyway, so we're going to talk about it. Now, I once thought that inches and feet and miles was perhaps the stupidest numbering or measurement system known to man. And then I met the apparent magnitude scale, and it's up there. This was invented by the ancients, Hipparchus, Ptolemy, I don't know who it was, and they decided that 6 here is the weakest star you can see in the night sky. Weakest star you can see with your eyeball. And then a star 1, they said, was 100 times brighter than star 6. And so if it's 6, it's really dim. If it goes down to 1, it's crazy bright. At least with inches and miles, at least it goes up, meaning longer. But here, it's reversed. The bigger numbers are dim. Let me just write that on here. Dim. The smaller numbers are bright. And then you can even go to negative. So you can have -5 over here. And so you might have a star that's the brightest in the sky, like Sirius. And that's going to actually fall on the negative a little bit. Something here in Manila about around a 2 or a 3, that's the dimmest we're going to see. We can't see anything up here in 6. There's too much light pollution, a little bit of haze. Over here, if you have Venus, which is usually the brightest thing in the sky, that's going to fall in the -3-ish area somewhere. The sun is way over here somewhere, like -25. The mathematics behind the scale from 3 to 4, how many times brighter 4 is than 3, is ridiculous. We're not going to talk about that. You can read about it. But the key is, with the apparent magnitude scale, it's only how bright it appears, and it may not actually tell you much about how powerful the star actually is. So the high numbers are dim, low numbers are bright. Apparent magnitude is represented with a small lowercase m. Another scale that we use that actually tells us how powerful a star really is the absolute magnitude. And with this one, we use the capital M as opposed to apparent magnitude small m. Now the official definition, let me drag this in. Take a minute and write this down. So you can think that if you take any of the stars that you see in the sky, and most of them are farther than 10 parsecs away, and you drag them in closer, if you then assign a number to say how powerful it would look at 10 parsecs, that's the absolute magnitude. And that would really be another way of measuring its luminosity. Now, the scale is also pretty stupid, much like apparent magnitude, where if you go up into the positive numbers, you end up with a weak star, with 6 being weak. And if you go in the negatives, that's powerful, very luminous. And so our sun, it's going to be somewhere around in here. The brightest star in the sky, Sirius, while it is very bright, it's not the most powerful because it's down here in the weak area at 1.4. But then you've got a star like Rigel. And Rigel is a ridiculous type of star. Maybe it's like a blue hypergiant or something. And it's way out here at like -8.1. Because it's ridiculously powerful. Rigel is the brightest star in Orion, and one of my favorites because it's so crazy powerful. There's apparent magnitude we're pretty certain of. This absolute magnitude is only an estimate, but -8.1 is ridiculously luminous, but it's really far away. So let's calculate how far this is. Pause it, see if you can use that equation that you just learned to solve it. The way you do that is you've got this equation And you got to keep track of these negative signs. You're going to have 0.12 minus a negative 8.1 equals all this stuff, and you're going to end up with a positive 7.92, and you divide it by 5 because you've got this, and you're going to end up with the 1.58 equals the log. And so then to get rid of the log, hopefully you remember some math skills. You got to do 10 to the 1.58 power, and that's going to get rid of your log. Then once you solve that, you end up with a distance of about 380 parsecs. But the question is asking, what is it in light years? So you go up here and you do the simple conversion, because as anyone knows, 1 parsec is big, and it's going to be equal to 3.26 light years. Those cancel, and you end up with about 1,200 light years away, and still it is so crazy bright here that it's one of the 10 brightest stars in the sky. Crazy.